is Rémi Colombet. I hope you can all hear me well. If not, say it in the Q&A box. I'm a policy officer at Ocean Energy Europe. I'm happy to welcome you all today to this webinar on Copernicus Marine Service data and ocean energy. As many of you know, Copernicus is the European Commission's flagship Earth observation program. It's marine service implemented by Mercator Océan, provides valuable data for ocean energy and covers the whole globe with long-term scales and proposes forecasts. Ocean Energy Europe is in a partnership with Mercator Océan to help its members access quality marine data and identify the needs of the ocean energy sector. Over the past 2 years, feedback from our members has fed the evolution process of the Copernicus Marine Service, and we are always looking for inputs, so don't hesitate to contact me if you want to share your experience. We've also seen an increased number of engineers and scientists from the sector register on the Copernicus Marine websites and use Copernicus Marine data during this period, and this showed that there's a real appetite for ocean data and these products. So this webinar is both for newcomers and users who are already familiar with Copernicus Marine and want to discover new features and uses. We're very lucky today to have highly competent speakers. Fabrice Messal, who's Education and Training Manager at Mercator Océan, will start and introduce you to the Copernicus Marine Service and present the new My Ocean Viewer. And after this, you'll get to hear the experience from end users from academia with Dr. Encarni Medina Lopez, who is Chancellor's Fellow at University of Edinburgh, and from the industry with Michael Henriksson, who's CEO of Wave Piston. They'll give you a good picture of what is possible to do with Copernicus products. Before starting these presentations, a bit of housekeeping. This webinar is recorded and will be available on the Ocean Energy Europe website. And if you have questions, use the Q&A box on the right side of your screen, and we'll take them at the end. Now I've talked enough, and we are moving on to the first speaker. Fabrice, I'll make you a presenter, and the floor is yours.
Thank you, Rémi, and thank you, Ocean Energy Europe, for this invitation. Hello, everyone. So my name is Fabrice Messal. As Rémi said, I'm a training and education manager at Mercator Ocean, and I will show introduction to the Copernicus the Copernicus Marine Service. So I'll try to share my screen. You see my screen? Yeah. Okay. Let's go. Quick reminder about the Copernicus. So for the people who don't know what is Copernicus, this is the operational and autonomous Earth observation capacities for Europe through in situ and satellite infrastructure development and data dissemination by thematic services. The Copernicus Marine Service is part of this Copernicus program because it's dealing with the validation and the dissemination of marine data. Behind this Copernicus Marine Service infrastructure, you need to imagine that there is a lot of producers of data, European producers of data, and you can have a satellite and observation center who's dealing with this kind of data, and also centers who's dealing with forecasting systems. Okay, and the Copernicus Marine Service is implemented by Mercator Ocean International, which is the instrumentality by the EU Commission to operate this service. So all marine and maritime professionals need to access information about the state of the ocean and its evolution. It's crucial for many professionals, and domain, the marine renewable energy, is also very, very important. So as you can see on this map, we are dealing with information about the blue ocean, what we call the blue ocean. This is physical and physical parameters like salinity, temperature, waves. The green ocean with information about chlorophyll, nutrients, etc. And the white ocean about the sea ice information. In your domain, the data from the Copernicus Marine Service are used or can be used to evaluate the resources during the farm prospection, the pre-feasibility of a project or the certification, to monitor and anticipate the constraints on the machine during the construction or during the operational phase, to prepare the operations at sea, and to monitor and report on environmental impact or status. The key things you have to keep in mind about the Copernicus Marine Service is that there is a single access point. This is a website, so marine.copernicus.eu. This is an open and free service. With a simple registration, you can access to all the catalog and you can download the data. All the data are scientifically and qualified products. The data are harmonized. We have the same format. We are dealing with the same format for all the data, whatever the source of the data. And this is a user-driven service. It means that we try to take into account user requirements to in the future evolutions of the service. And to support all the audiences interested by marine informations, we try to give access to 3 different kind of information. The core data, the ocean products, the ocean monitoring indicators, and the ocean state report, which is a high level of expertise. And I will give you an overview also of our new tool for ocean visualization directly plugged on our data catalog. So about the data, the core offer of this service, we have a catalog with data from different sources. They can be in situ data, satellite data, or modeling data. They cover a large temporal coverage with reanalysis over the 25 years in the past, real-time data with daily and hourly updated data, and forecast for some of the model data, forecast data up to 5 or 10 days following the system you're using. All the data cover different geographical zone. You have the global one, and then we have the different European basin with the Arctic, the Northwest Shelf, the EB region, the Mediterranean region, and the Baltic Sea, the Black Sea. So as I said, we have 3 different sources. Satellite data, we provide information on the satellite data with 2 levels of processing available. The L3, what we call the L3 and the L4. The L4 data can be daily interpolated data and gridded data. And for the L3, you can access to a long track product or grid product. The data you want to use. The in situ data are come from different networks and platforms. This is European networks or even global networks who share this information. So we give access to all this information on the website, and also model data. So we have different modeling forecasting center. We're dealing with different regional and the global one, the global model. We're dealing with this 3D numerical representation of the ocean. And this is very interesting because you have access not only to the surface of the ocean, but also in different of the ocean. And thanks to the model, you can have also forecast in the future days. Okay, this is just an overview about the data. This table is just an extract to allow you to understand what kind of data is available. So you have blue ocean parameters, white ocean parameters, and green ocean parameters. And you can see for satellite observation, you can have data from the past and near real-time data. It's the same for in-situ data. But these data are available only for on the surface or up to 2,000 meter depth of the in-situ data. And thanks to the model, you can have access to surface to the bottom of the ocean and 20 years in the past, today, and 10 days forecast. Second level of expertise we propose on the website of the Copernicus Marine Service, the ocean monitoring indicators. The ocean monitoring indicators are key variables to monitor the health of the ocean. This information is crucial for people like scientists, or decision makers, or environmental agencies, or general public who want to know better the role of the ocean in the climate change mechanisms and the impact on the ocean about from the global world. So this is not core data. You can access to the core data, but you can access directly to the maps and to the infography and to these trends. And finally, the third level of expertise, the Ocean State Report. It provides a comprehensive state-of-the-art assessment of the state of the global ocean and the European regional seas. And the audience of this report is the general public and the ocean scientific community, as well as for policy and decision makers. Recently, we published the summary of the issue 4, and you can find this document directly on the website. And also we edited the Blue Book. This is a report to explain how the Copernicus Marine Service benefits society as a whole. So it's very interesting to discover all the user testimonies in this book. Supporting users is one of the Copernicus Marine Service commitments. We have a unique service desk with a lot of information on the website, with a FAQ, a collaborative forum. You can find on the website also online tutorials and more than 100 use cases where you can discover how people are using our data. And we try to, the service desk also here to inform all the users about the next release of the catalog, the continuity of the product, and if you need help to find a relevant data or product for your activity. So this is some example of the use case you can find on the website. You have different web mapping tool, application to characterize the sites for renewable energy or aquaculture activities, Metocean tool for navigation, etc., etc. And we are also involved in training activities and outreach activities because we are also committed to share knowledge. So we organize a lot of training workshops each year to exchange and to with future users about their needs, their requirements, and to explain them how to use the data. So we try to share codes, etc., etc. Just a few words about the training, because perhaps you might be interested to participate to the next one or perhaps ask to Ocean Energy Europe and Mercator Ocean to build a workshop in. So today we provide online training with a new format because of the COVID crisis, with new tool and new material. So we provide to all the participants to this training Jupyter notebooks. We work on a Jupyter Lab platform on codes, and this is very relevant tool for training because we can share code with the participant. They can learn how to use our data. The experts developed these codes, also record a video to explain what they're doing. So it's very interesting to see that. And today we have more than 60 Jupyter notebooks validated by the experts. A lot of tutorial videos available on our YouTube webpage. We have also some sessions GIS tool. So it's a large amount of information you can find through this webinar, this training material. So this is an overview of the past events this year. We trained more than 1,000 people. In fact, not only in Europe but all around the world. The last event for this year is scheduled for the 1st December, and it will be a training workshop dedicated for the Arctic Ocean. So thank you. I finished this overview. Now I can show you quickly our new tool. When you start to navigate on the website, so you can have access to all the information I already talked about. So the use cases, the different news and events, the access to the Ocean State Report and the OMI, some information about the education and the training activities, and the shortcode service to the online tutorial, the scientific quality, etc., and the button to register. So you can have access to all the catalog of products here. You have just to click. Okay, you can search by keywords. You can search by regional domain, by parameter, by temporal coverage, etc. And you can, for some data, you can have a subsetting function to extract only the data you need on your region of interest. But to do that, you have to be first registered. Let's dive now to the ocean visualization tool. So I'll try up here. Okay. So this is it. I already upload some layer to show you this. So you can add a layer easily. You have just to click here to select your variable of interest here, the area of interest, the time you need, if you need information in the past or near real-time information, the source of information, the region, etc., and the community. Here we have already a community for natural resources and energy, and you can browse all the catalog, and for a majority of them you can add to map. So you have just to for example, this is temperature. I can select the global one, select to add to map, and then I can I have the choice between several data sets. Mean data set, hourly mean data set. So I can choose this one and just to add to map, and then I have the information display on this map. Now we are watching the seawater velocity. This is regional products on the Norway shelf. Okay, so with this viewer, you can configure your layer. You can change the color map and the boundary of the color map. You can change the scale, if you want a logarithmic scale or not. You can play with the transparency of the layer. You can explore from this dataset other parameters. You can have information on the data. And you can directly download the data. This is a link to our catalog of data to download the data directly from the website. And you can have different kind of layer. This is the seawater velocity, but I can show you seawater wave significant height here on the EB region, the global one here. So you can have this information, and you have a timeline at the bottom of the screen, and you can play with the timeline to change your data to change your timestamp. And for some of the data available on the different level of depth, you can have access also to this level directly on the bottom right of this tool. You can also select a point to have information on the data. If I click here, you can have some information updated directly on the screen. I'm sorry because I have a bad connection. I'm work from home and it's complicated sometimes to make a live demo, but it's working. You can test at your office or at home on your computer. You can choose a line, you can choose an area of interest and see the evolution of the parameter on this line, on this visualization. Okay, if you want to share this, for example, you want to share information with your colleagues, you can click here and you have access to this different button. You can share directly the link to this image, or you can download the image and you can also put a video. You have just to choose the start and the stop time of the video, and you can generate the video, download the video. You can embed it, this part of the website on your own code. So I think my time is finished. So I stop sharing my screen. Thank you very much. I'm still available for the question at the end of this workshop. Thank you very much.
Thank you very much, Fabrice. It was very interesting. We're now moving on to the experience of end user, and we'll start with a presentation from Dr. Encarni Medina Lopez from the University of Edinburgh, who will present about her research and how she uses Copernicus products. The floor is yours.
Thank you, Remy. I'm going to start sharing my screen. So hopefully you can see now.
Yes.
Perfect. So yeah, good morning, everyone. As Remy said, my name is Encarni Medina Lopez, and I'm a Chancellor Fellow at the University of Edinburgh in Scotland. And I've been working with Copernicus data for the past 2.5 years or so, and my main research focus on the use of these products. So I'm going to speak today about specifically ocean waves, temperature, and salinity from Copernicus data. So starting with ocean salinity and temperature, the motivation for this work was that, as we all know, ocean salinity and temperature are very relevant for marine renewables in terms of the different products that we can use to estimate resource in the ocean, but also in terms of environmental impact assessments, for example. But salinity and temperature are also very important for climate change and to understand human impacts in the coast and in the ocean. The existing information about salinity and temperature are based on buoys, vessels, and other platforms. We also have numerical models, but the problem with numerical models is that they need boundary conditions and validation data. And then the idea was to develop a satellite-derived product for salinity and temperature at high resolution. And in that way, we don't depend on specific platforms and we don't depend on numerical models. At the moment, there are some satellites that provide this information, but the resolution is very poor. 4 kilometers for temperature and 35 kilometers for salinity. And this work provides a resolution of 100 meters. This is particularly relevant around the coast because, well, it's where we do many of our activities, and satellites work not particularly well around the coast due to land adjacency problems. So in this case, I've used the Sentinel-2 data, level 1C, and essentially it has 13 spectral bands from resolutions ranging from 10 to 60 meters and a revisit time of 5 days, which means that the satellite passes through the same point every 5 days. And the data is available from 2015. So some of the information we find in Sentinel-2 is bands related to red, green, and blue, as we are used in any other image. But we also have information about water vapor, near infrared, shortwave infrared, and many others. In this case, I also decided to use level 1C, which is top of atmosphere data, to avoid losing information, because when we go to bottom of atmosphere, we have to apply atmospheric corrections, and the process is slow, and we lose data. A link to Sentinel-2, I also use Copernicus in situ data. And in this case, I use more than 14,000 valid platforms around the world. The results of this project that I'm presenting here are available in this source down here if you want to check the specific details. And here you can see an image of those 14,000 platforms that were used for this work. All of these are buoys, vessels, marine mammals, and other platforms available in the Copernicus Marine website. So everything is free of use. And essentially, the main methodology was using a deep neural network, so some machine learning, in order to match the in situ data with satellite data. So Copernicus provides an in situ data flag system, which means that you can select the level of quality of your data. And I use only very good data. As I said, the data was selected from the satellite in a square of 100 meters around the platform locations, the 14,000 platform locations. And temperature and salinity were trained independently. And the neural network was trained for 2 types of problems. The first was an interpolation problem, where we give the neural network a section of the data of every platform, and then we leave another section of each platform to be tested afterwards. And once the neural network kind of learned this problem, we gave it another more difficult problem, which is extrapolation, which means that we will leave specific platforms outside of the training data set for the neural network, which makes things more complicated because it's data that the network has never seen. And well, going to the results in terms of temperature, these are the errors. The colors depict the errors from 0 to 2 degrees, with the most common error being around 0.4 degrees Celsius. And as you can see, in many cases, the error is much lower than that, it's around 0.25. So the results are pretty good. and this is all derived from satellite data. And in terms of salinity, I have to say that these are not the most recent results for salinity. There is a new paper from a couple of months ago where the most common error now, after developing an improved algorithm, is around 0.2 PSUs. And we can see here that also in each platform, the errors are very, very small. Also, in many areas in the Mediterranean, close to zero. So this means that we can use this Copernicus data, this Sentinel-2 data to derive salinity and temperature. Once the data was tested for the different platforms, the next thing I did was to apply the results of the neural network in every pixel of each satellite data, and the results were these for 4 months of the year. So we have spring, summer, autumn, and winter, and we can see temperature range, and we can see river inputs to the ocean. This image is taken in the southwest coast of Spain. So we can clearly see temperature patterns derived from the neural network. And remember that this is all based only on satellite data at this point. And in terms of salinity, it's the same 4 months of the year, and we can see clearly the riverine input with the fresh water going into the Atlantic Ocean. We can even see some eddies in this figure, and we can see longshore currents carrying salinity. So the results are very, very promising. The second part of this presentation is about ocean waves. And this is a work that we have been carrying out as part of a SuperGen ORE funded project called SCORE. And SCORE stands for Satellite Climate Observation for Offshore Renewable Energy Cost Reduction. And in this case, I'm just showing a section of the results of this project, the one that focuses on significant wave height. So what we did in this case was to use the altimetry data available in Copernicus. In this case, there are 4 different altimeter missions, and they provide data on significant wave height. The data is available every 3 hours, and the grid is 7 kilometers by 7 kilometers. And well, as you saw before, this is how the Copernicus Marine Service looks like. And the specific product that we used was this one. And you can see here that in the case of the altimeter, we only have the trajectories of the satellite. So our goal was to obtain from those trajectories a graded product that we can use in a specific location. So in reality, those lines that we were seeing before, those trajectories, if we plotted in latitude and longitude, they look like this. So as you can see, we don't have data in every point. And we decided to focus on the area around the Beatrice offshore wind farm in Scotland. And this is the final product that we have. So this is significant wave height in this big area, while the yellow area is the specific one on top of the offshore wind farm area. And in order to obtain this, the process that we followed was this one. So we took one of the buoys from CIFAS, and the one that is available in the Moray Firth, and we compared the significant wave height from the buoy to the significant wave height from the satellite. And in the horizontal axis here, we can see the distance, the kind of smallest distance from the satellite trajectory to the buoy. And we could see that the bigger the distance, the bigger the error, obviously. But also there was not a clear trend. So we needed to do something about this. And essentially after trying many things, what we did was to take a 24-hour window to take all of the satellite trajectories that pass around the buoy in that 24-hour window, and applying an interpolation algorithm, we managed to take all of the data provided by the satellites, by the altimeters in that area around the offshore wind farm in the 24-hour period. obtaining the results that we can see in this figure. So here we can see significant wave height for the different days of the month. And of course, we don't have satellite data for every day of the month. So that's why the blue stars depict the interpolated value from the satellite in the specific dates where we have satellite data. And the black bars represent the data from the buoy, with the orange line being the mean or the average of each day, and the range of the black bar showing all of the wave heights that we had in a given day. And the result with this interpolation algorithm was that the error that we get, as you can see, is quite small. And the average error that we get with satellite data is 0.5 meters, which we consider that is a very, very good result, taking into account that this is the specific wave height in a specific point obtained from satellite data in a different location that is not exactly that point. So this is how we obtain our gridded product that we saw in the first slide. And that was everything I wanted to show you today. I'm available for any questions at the end. And that's everything from my side. So thank you very much.
Thank you very much for this insightful presentation. We're now moving on to Michael and Erickson's presentation. Michael, the floor is yours. I'm going to make you a presenter now.
Thanks for inviting us to present a bit about our experience with Copernicus. And we are, compared to the previous ones, we're a bit sort of more less sophisticated, more low practical use of the Copernicus data. So first of all, just a bit about wave piston. So what we're focusing on, we have the freshwater. We do desalination. And how do we do that? Well, it's our wave piston system is a number of what we call energy collectors, and they are plates connected to each other. And as the wave pass by, they move back and forth. And this pumping movement creates pressurized water, which we can use for conversion to electricity or for desalination. No more about the technology. So any questions, just come back to me later on. Where are we now? The status is that we are running the first sort of full-scale systems. We're preparing those installations. We have 2 EU-supported projects at the moment. One is the competitive wave energy on islands, where we are going to just focus on the power generation side. We're going to connect to the grid via the Glocan platform at Gran Canaria, so it's in the Atlantic Ocean. The other project is with a consortium with Fjellberg Hydraulic Partners, Freihof is our mooring partners, and NMS on the grid side. And here we have this combined solution of both desalination and power. So how do we use this with the Copernicus? So why are we using Copernicus? So that's what sort of the questions also that we were asking, why and what and how are we using this? So that's what I'm trying to say here. First of all, why is that? Because it's good available data that we use in our pre-studies on the wave piston potential. And so this is for free, and it's very good data that we can assess. So we have the wave current type. So what we do is we can go in and then we can choose a specific location. That this is just a theoretical case here. We have someone contacting us, let's say from the Galapagos Islands, saying, okay, we are interested in your technology. What is the potential around here? So what we have from the Copernicus, that's the waves, current and tide, and we focus on the waves to start with. But of course, also looking at on the potential, we also need to understand some geophysical conditions and also the extremes, which is, we're not taking that from any Copernicus, anything else, but that's also important in this assessment. But just focus on the first step, that's actually looking at the waves. There we take the data from the Copernicus database, and what is interesting for us, that is the significant wave height, is the period, TP, and the direction of the waves. We download that, and then we put it into our MATLAB code, or my colleagues do all these things, and then we can sort of analyze both the significant wave height, the period, and direction, and then based on that, looking at these different charts, we can choose the best locations, specify the more specific place, and that then leads us to the next phase where we isolate the data and then get more details on what a specific area, the scatter, so how is the wave climate specifically there, the direction, and also how it fluctuates over the years. So it's the seasoning. So the more seasons, of course, the less good it is, the more stable, the better. But anyway, this is sort of the input. And then we can just run what we have. We have this energy tool we have developed together with the Technical University of Denmark, where we can sort of input the wave data and see how much energy to expect to be able to harvest on a specific one string of wave piston, of the wave piston string. And this then gives the input, say, okay, is this a go or no go to go more in detail? If it looks okay, then we start looking more in the cost tool, estimating the capex and the opex side of things to get the levelized cost of energy and levelized cost of water, depending on what we need to focus on. And as I said before, besides then looking at just energy, then of course, what is also important is to understand, where can this be located? So how does the seabed look like, etc. But also the extremes. Are there many extremes there, or high extremes? Then it also impacts the cost side and the priority of where we want to install the first systems. So this is sort of the most important, that is to have this pre-study, to have the go, no go, to go more in detail, to continue discussing with these potential customers. That was it, short and sweet. Thank you.
Thanks a lot, Michael. Now's the time. If you have questions for our speakers, obviously, if you don't at the moment, or if you can't think of something right in the moment, we are always available afterwards. I think we'll share the presentations if the speakers agree to do so. And if you have technical questions, the help desk of Copernicus is always available. If you want to share your experience and have ideas of how to improve your experience and the system, and if you need more data than what's currently available, you can always contact me, and I will feedback your feedback to Copernicus. Obviously, we'll share with you the dates for other webinars, and if you need something specific, just ask us and we'll see if it's possible to organize it. I see a question: is it possible to download data from Copernicus website with a Python script, for example?
Fabrice?
Yes.
Yeah.
Can you hear me?
Yeah.
Yes. Yes, you can do that on the website. I can try to show you, but on the website, when you access to the product, you can have the part of the code you have to copy paste in your Python script to access your data.
Thanks a lot. Other questions? Otherwise, I'd first like to thank all the presenters who shared their experience today, took the time. There's another question. Can you tell us what software platform is used to visualize the data on your website, Fabrice?
You can go directly on the website to know this provider. The engine is called Lobelia, and this is the name of the company.
Joseph, data in the atmosphere.
I can see the question.
Okay.
Sorry.
Good. It's perfect.
So do you have in the atmosphere? No. We are dealing with marine data. We have some data, some wind data, but this is also data we are using for our models. So if you need atmospheric data, you have the atmospheric service, the Copernicus Atmosphere Service, monitoring service, the CAMS. The interested entity behind the CAMS is SMWF. So you can have access to the data from their catalog. And if you need to use at the same time marine data and atmospheric data, you can find a solution on the Wikio platform. Wikio is a data information access service. This is a Copernicus DIAS implemented by Mercator, UMETSAT, and SMWF. And the catalog of Wikio is all the Copernicus data and the Sentinel data. So you can have access to the different portfolio of each services at the same time on the same platform. And if you need also computational resources, you can find them on the Wikio platform also. So it can be a good solution for you if you need to mix informations from different environments.
There's a question for Michael. As an input for the wake power output evaluation for HS and TP, do you use scatter diagrams or spectra time series?
We use, say both, but it's a scatter diagram to begin with, just to get an idea, just sort of for the analysis. So we get an idea which ones looks best. Of course, we want the higher and the shorter, the higher the wave and shorter period. That's the best for us, of course. So we take the different scatter diagrams and then analyze that, and then based on that we can enter the data into our energy tools where we get the specific conversion, so the specific power production. But to start with, it's just to get an overview. It's a general analysis of the scatter diagram.
Okay, thank you very much. There's another one, I think, for Fabrice. What advantages has Copernicus compared to reanalysis data from, for example, ERA5?
ERA5 is provided by SMWF, who is a Copernicus service. So this is the same service, in fact. It depends what you want to do. You can compare the different reanalyses on the domain of interest or the area of interest you want to study. Okay,
thanks a lot. Do you provide data on plastic pollution in the ocean?
No, not yet. We developed some codes with the Jupyter notebooks to show how to build a drift simulation from the Copernicus Marine Service currents. But today we don't have this kind of information.
Okay, good. I think we will close here. This concludes this webinar. Thanks again to all the speakers who presented today. Thank you for the time, taking the time, sharing the experience with the community. We'll keep you posted on the training opportunities in the future. And in the meanwhile, we hope to see you all at virtually at Ocean Energy Europe 2020 next week, our annual conference and exhibition. Have a good day all, and thanks again. Bye.
Thank you, Remy. Thank you. Bye.
Thank you.
Thank you. Bye-bye.